Hi everyone, so in this video we're looking at examples of factorisation, and as always the examples that I'll be using are available in the link in the description so you can have a go at them yourself, and there's also some different timings for the video there so you're able to stick to a certain question. Now we'll jump straight in and start the examples. So the first set of examples are just using positive numbers, and the first question asks us to factorise the following expressions. Now the first example we have is 3x plus 15. So I'm just going to write this underneath. So we have 3x plus 15. And I'm going to put an equal sign and just leave it there, and we'll fill that in later. So what we're asked to do is we're asked to factorise this expression. So it means we need to take any common factors that the two terms share and then multiply it by some stuff. And then if we was to expand our factorised version of the expression, we'll get what we originally started with. So let me show you what I mean. So if I take the highest common factor of 3x and 15, so I'm just going to write HCF for highest common factor. So I'm going to take the highest common factor of 3x and 15, and then this is equal to the highest common factor of 3x and 15 is going to be a factor that both 3x and 15 share. So we can see that the 3x has an x attached to it, but the 15 doesn't. So we know that the highest common factor doesn't involve an x. So we just have 3 and 15. And the highest possible multiple of 3 and 15 is 3, as 1 times 3 is 3, and 3 times 5 is 15. So that means the highest common factor, 3x and 15, must be 3. And now that we've found what the highest multiple is, this is now the factor that we need to take out of 3x, and we also need to take it out of 15. So the way I like to do this is I like to write underneath. So if we have 3x divided by the factor, which is 3, we're going to be left with x. And then if we have 15 divided by the factor, which is 3, we're going to be left with 5. So this means we're able to write that our factor that we factored out, which is 3, times by what we're left with, which is x plus 5. And then we're able to check this over here just to double check that we haven't made a mistake. So we should be able to expand this now and then get to our original expression. So we have 3 times x plus 5 is equal to, well, if we do 3 times x, we get 3x. And if we do 3 times 5, we get 15. So that means that 3 times x plus 5 is equal to 3x plus 15. And we can see that 3x plus 15 is the original expression we had before, so we know that our workings are correct. So in our answer line, we'll write 3 times x plus 5, which is the factorised version of 3x plus 15. So let's do another example. So we have 3a plus 12, so I'll just write that underneath. So 3a plus 12. And that's going to be equal to, well, we need the highest common factor of 3a and 12. So there isn't an a in both terms, which means we can't factor out the a. So we're just left with the 3 and the 12. And the highest common factor of 3 and 12 is 3, as we have 1 times 3 is 3 and 3 times 4 is 12. Then we divide both our terms by 3, so we have 3a divided by 3, which will leave us with a. And we have 12 divided by 3, which would leave us with 4. So if we piece this together, we'll get our factor, which is 3, times by a plus 4. And then we can just check this over here just to make sure we haven't made any mistakes. So we're saying that 3 times a plus 4 is equal to, where we have 3 times a, which is 3a, and then we have 3 times 4, which is 12. And we end up with 3a plus 12, which is our original expression. So we know that our workings out is correct. So that means on our answer line, we need to put the final answer of 3 times a plus 4. Now the next question we're going to move on to has a squared term. So this is where things get a little bit more tricky. So we have a squared plus 4a. So I'll just write that underneath again. So a squared plus 4a is equal to, and we need to find the highest common factor of a squared and 4a. So we have the highest common factor of a squared and 4a is equal to, well, this time both terms contain at least one a, so we know that a is going to be part of the highest common factor, And we have the coefficients of a as 1 and 4, so the highest common factor there is just the 1. So we just leave it as 1a. So then we have a squared divided by a is equal to a, and 4a divided by a is equal to 4. So now if we piece this together, we have our highest common factor, which is a, times by a plus 4. And then we can check this to get a times a plus 4 is equal to, and we have a times a, which is a squared, and then we have a times 4, which is 4a. So that means a times a plus 4 is equal to a squared plus 4a. And that's our original expression. So we know that our solution is correct. So on our final answer line, we can write a times a plus 4. So now hopefully you realise that this isn't too bad. There is a few questions here for you to just have a little practice with, and then there's some solutions in the description so you can check your answers. But if you use what we've just done as a guide, you should be able to answer these quite easily. So next we're going to move on to negative numbers, but we're still doing symbol brackets at the moment. So the first question is asking us to factorise the following expressions again, and the first expression we have is 3x minus 12. So I'll write that underneath, 3x minus 12 is equal to. So we'll first take the highest common factor of 3x and minus 12, so we need to make sure to include the minus. So we can treat this as we would if it was 3x and 12. So only one term includes the x variable, so we know that the x variable isn't going to be part of it. So now we have 3 and minus 12, so we know the highest common factor is 3. Now if we do 3x divided by 3, that's equal to x. And then if we do minus 12 divided by 3, that's equal to minus 4. And then if we piece these together, we have our highest common factor, which is 3, times by x minus 4. And then we can double check our answer. So we have 3 times x minus 4 is equal to, well, 3 times x is 3x, and 3 times minus 4 is minus 12. So 3 times x minus 4 is equal to 3x minus 12, which is the original expression, so we know our solution's correct. So on our answer line, we just need to write 3 times x minus 4. Now our next question is AB minus 2A. So we have AB minus 2A is equal to the highest common factor of AB and minus 2A. So we have A in both terms this time, so we know A is going to be part of the highest common factor. And then we're left with B in minus 2, which has the highest common factor of 1, so we're just left with A as our lowest common multiple. So now if we divide both terms by a, so we can take a factor of a out, we have ab divided by a, so we're just left with b. And we have minus 2a divided by a, so we're left with minus 2. So now if we piece this together, we have our factor of a times by b minus 2. Now let's just double check this. So if we have a times b minus 2, a times b is ab, and a times minus 2 is minus 2a, which is the original expression, so we know that's correct. So on our answer line, we'll write a times b minus 2. So hopefully you've realised that this is pretty routine, you just have to follow the same steps. But I'll do another 2 examples which do look a little bit trickier, but you'll realise we're just doing the same thing. So we have minus 3w cubed minus 4w squared is equal to. So we'll first take the highest common factor of minus 3w cubed and minus 4w squared. So we can notice straight away that both terms include w, and the first term is w cubed and the second term is w squared, so both terms must at least include w squared. So we know that w squared is part of our highest common factor, so that means we're just left with minus 3 and minus 4. And the highest common factor there is just minus 1. So they're both minus numbers and they only have 1 in common. So we're left with minus 1 times w squared, which is obviously just minus w squared. Now we'll divide that by both the terms to take a factor of minus w squared out. So we have minus 3w cubed divided by minus w squared. So that just leaves us with 3w. and we have minus 4w squared divided by minus w squared, and that leaves us with 4. So that means we can piece this together and put our factor of minus w squared times by 3w plus 4. And then we'll double check this, so we have minus w squared times by 3w plus 4 is equal to, so we have minus w squared times 3w, which is minus 3w cubed. And then we have minus w squared times 4, which is minus 4w squared. So that's the original expression, so that means our solution is correct. And then on our answer line, we'll write minus w squared times 3w plus 4. And then the last one in this section is 4a squared minus 6a minus 4ab is equal to, so we can notice straight away that all three terms include an a, so we know we're going to have the highest common factor of 4a squared minus 6a minus 4ab is equal to a. And then let's see if there's a highest common factor between the 4, the minus 6 and the 4. So the 4 and minus 4 multiples of 4, but minus 6 isn't. So the highest common factor must be 2, because 4 and minus 4 multiple are 2, and so is minus 6. So we're going to have 2a. And then if we divide each term by 2a, we have 4a squared divided by 2a, which is equal to 2a. And we have minus 6a divided by 2a, which is equal to minus 3. And then minus 4ab divided by 2a is equal to minus 2b. So then we have our factor of 2a times by 2a minus 3 minus 2b. And then let's just double check this. So we have 2a times by 2a minus 3 minus 2b. So we have 2a times 2a, so we have 2 times 2, which is 4, and a times a, which is a squared, so we have 4a squared. And then we have 2a times minus 3, which is minus 6a, and 2a times minus 2b, so we have 2 times minus 2, which is minus 4, and then a times b is just ab, so minus 4ab. So we're left with 4a squared minus 6a minus 4ab, which is our original expression, so we know our solution's correct. And then on our answer line, we'll write 2a times by 2a minus 3 minus 2b. So like I said earlier, it is pretty routine, and it's just that the more terms you have, then the more terms you have to check. But there is some questions for you to pause the video and have a go yourself, and then check them against the solutions. But just make sure you compare it to what we've just done if you get stuck.